So as Martin said, my name is Mikolaj Lula, and I did my PhD down in Alnarp, and now I continue as a postdoc. And the main focus of my research is different issues related to regeneration of pine, but also long-term production comparisons between Scots pine and Norway spruce. And that's what I will mostly talk about today. I will start the presentation with this study where we try to compare production of Norway spruce and Scots pine during the rotation. And then I will also talk about short-term regeneration studies, mainly based on the experiment established at Togge, which some of you might be familiar with. And in that experiment, we compared natural generation, direct seeding, and planting. So that's what I plan to talk about today. So I guess this is quite obvious and well known to most of you. But as an introduction, I wanted to say that both Scots pine and Norway spruce, they have different growing patterns. Scots pine is a pioneer tree species, which has a quite rapid initial growth, but on the other hand, quite early mean annual increment culmination. And on the other side, we have Norway spruce, which could be considered more as a late successional tree species, with which is more of a slow starter, but on the other hand, it has a relatively late culmination of growth. And both species, they have not only different growing patterns, but they have also different requirements when it comes to site conditions. And what you can basically read in the forest handbooks is that pine is recommended more on low fertility sites, sandy sites, and dry sites, and whereas Norway spruce is recommended on higher fertility sites. And somewhere in between, you could also have also mixtures of pine and spruce, and on very rich fertile sites like the ones in Skåne, you could establish broadleafs, for instance, noble broadleafs. And this seems to be probably obvious to most of you or everyone, but it's not what is actually reflected in current management practices. So if we look at the next slide, and this is the data from the Abbin inventory, where the stands are approximately in the age of first PCT, so approximately 15 years old. And we look at the region of northern Sweden, you can see that regardless of the site fertility class, Scots pine is actually a preferred species in regenerations across the entire range from low to high. And if you look at southern Sweden, you can see that the trend is totally opposite. So it's Norway spruce that is predominant tree species in regeneration across all fertility classes. So you can see that this contradicts a lot what you saw in the last slide, showing the general recommendations for both species. And that was one of the motivations why we decided to conduct our study, where we compared the long-term growth of Norway spruce and Scots pine. And in order to make this comparison, we used 102 species comparison, which are distributed across entire Sweden from south to north. You can see that maybe we lack some of the sites in central Sweden, but we got quite nice representation of the sites both in the northern part and southern part of the country. Sites are representing quite a wide fertility range. But the main problem was that most of the stands, they haven't reached the mean annual increment culmination, and the only fair way to compare growth of both species would be to look at the entire rotation. So it means that we were forced to use simulations, and we did it with Heureka standwise application. And the outcome was evaluated in terms of mean annual increment ratio between Scots pine and Norway spruce. And I imagine that maybe that is not straightforward what I mean here. So I will try to use the example to visualize what we actually did. So if we take one species comparison of Scots pine and Norway spruce, and in that case, the actual stand was 30 years old, and that was the starting point of our simulation. So the rest of the growth of both species after 30 years old, when the stand was measured, was simulated in Heureka. So you can see how we simulated the mean annual increment for Scots pine, and then we did exactly the same for Norway spruce. The next step was to find a culmination of mean annual increment for both species. And then out of that, we calculated the ratio. And this is how we expressed, how we compare the growth of both species. But that was just example for one stand, and we did exactly the same for all 102 species comparison. And this figure actually presents the main result of that study, where on the y-axis we have mean annual increment ratio between the two species, and each dot represents a single comparison of Scots pine and Norway spruce. So I hope we see here 102 dots. And then we have a dashed line in the middle, which is a ratio line. So basically what it means that all the dots that are above the ratio line is where Scots pine outperform Norway spruce. And all the dots that are below the ratio line is actually where Norway spruce yielded a higher production compared to Scots pine. So the main conclusion from that according to our result, Scots pine is actually yielding higher growth up to 30 or even over 30 meters of side index estimated from top height. And similar studies was done earlier by ECHO in 2008. And basically the concept of the study was very similar. However, for their simulation, they use SIS, so side index estimated from site properties. And what we did, we used SIH, so side index estimated from top height. And that's the one of the differences between these two studies. And what you can see is that actually they found out that Scots pine is producing more than Norway spruce only on low fertility sites, whereas Norway spruce produce higher volume production on medium and high fertility sites. And what our study showed is that actually that was not the case, and Scots pine can produce higher on medium fertility sites as well. So this is the main difference compared to a study by ECHO. And to conclude, Scots pine has shown better results on all sites except most fertile sites, where actually Norway spruce perform better. And our hypothesis is that one of the main reason for the difference of our study compared to earlier study is the way how side index was estimated, meaning that we used SIH and ECHO, and most of the earlier studies they use SIS for the simulation. And then we conclude that wrong or suboptimal tree species choice can lead to substantial production losses and in consequence also financial losses. I guess our main message would be, we do not want to encourage anyone to establish Scots pine on side indexes around maybe 30 meters. But what we want to show is that actually the range of the sites where Scots pine could be used, it's much wider than we thought before. So for instance, planting planting Norway spruce on low fertility sites, which is often the case in southern Sweden to, for instance, avoid browsing, could have a serious consequences both on production and consequently also on financial losses. Okay, and with this, I would like to move to the outcomes from our short-term regeneration studies, where we try to compare natural regeneration, direct seeding, and planting on the same site. And such experiments are quite rare. So most of the knowledge that we have is relying on the comparison of different methods between the sites, often neighboring sites. And the results that I will mostly refer to, they come from the experiment located at Togel Estate, which is maybe 20 minutes drive from Alvesta. And this experiment was divided into clear cut, spare shelter wood of 100 trees per hectare, and dense shelter wood of 200 trees per hectare. And we also replicated this experiment 3 times in time. So first replicate was established in 2017, second was established in 2020, and the third one is actually about to be established in this year, this spring. So cuttings are performed right now. And in this experiment, we are looking at different treatments, and I don't think we need to go into detail, but some of the treatments that we are testing are the effects of mechanical site preparation, herbicides, insecticides, seed type, and seedling size. And I will just show some of the results. So as I said, we have 3 replicates in time to account for the variation in weather. And what is important to mention that all of the replicates are fenced. So actually browsing was not a part of the study, as probably it would affect the results quite a lot, or could be that there would be no results at all. We don't know that. And I will start with discussing some results from the part that is focusing on natural regeneration. So when you want to conduct natural regeneration in pine, first what you should think about is the overstory. So you would like to think how many overstory trees you would like to retain. And usually in Sweden, it's something between 50 and 150. It depends on wide range of factors, such as site fertility, also your management objectives, and so on. And I will touch upon that during the presentation as well. And the most common way to conduct natural regeneration in Sweden is to use uniform shelter wood or seed trees, where the trees are uniformly distributed across the area. But in other countries like Poland, for instance, management with strip cuttings or gap cuttings are also quite common. And what was found that actually 3 sites, mainly diameter at the breast height, is well correlated with seed production. So when you select your trees that you want to retain, it's good to select thick trees. And also one way to do it is to look at the crowns and how they are developed, and if they are producing a lot of cones, then could be another indicator which trees should be retained. And the important factor when conducting natural regeneration is wind speed and wind direction. So basically, conducting shelter wood cuts could be compared to doing thinnings in a very late stage. So it increases the risk of damage to the remaining stems. And then you also would like to think when to remove your stems, and that's something that I will talk about a bit later. So this is results from the Linebjerke, which is quite a similar experiment in terms of design and the whole idea. So what you see on that graph is actually seed fall. On the y-axis, you have number of seeds per square meter. And on the x-axis, you have different years. So that particular experiment was established in 1992. But as you can see, rich seed fall occurred in 1997. And you might wonder why that happened. And probably the main reason for that, as some of you might remember, the year 1994 was the year of World Cup, but it was also the year when it was very warm. More particularly, it was a very long and warm summer. And weather conditions have a big impact on seed production. So probably the very good seed year in 1997 could be a consequence of that. And if you still do not follow what I'm talking about, is that weather condition in the 3 preceding years of the seed fall, they actually influence the seed production. So warm and dry summer in the first year indicates flowering for the next year. Then the second year we have flowering and pollination, where dry and windy weather is preferred. The third year is the actual fertilization and maturation of the both seeds and cones. And finally, in the fourth year, we can accept seed fall in early spring between May and June, depending on where we are in Sweden. So the effect of this dry summer in 1994 could actually is seen after 4 years. So that's why it's a little bit postponed in time. So that could be one of the explanation of what was observed in Lüneburg. And this is actually similar result from the experiment at Togel. This experiment was established in year 2017. And what we've seen is that we observed quite a good seed year in 2020. And the reason for that is slightly different. This time it's not weather or dry summer, but we would explain it rather with the release effect. So when you will do the release cut, you remove most or some of the trees, reducing the competition for the trees that are retained. So you reduce the competition for both light, but also nutrient, and that's why they respond with producing more seeds. And again, this effect cannot be realized earlier than 4 years because of the because it takes 3 years to develop the seeds for pine. Yes, and then Christer Carlson, he conducted the study looking at the effects of release on cone production and seed production. And in his study, he concluded that number of cones was almost double after 4 years after the release cut. So that's actually what that graph is showing. So it's exactly this effect, the release effect that I was talking about. And actually one of the few remaining questions about regeneration of pine is where should you conduct mechanical site preparation when you want to do natural regeneration. So one option would be to conduct mechanical site preparation straight after the release cut. And that's actually what is practiced in practical forestry. That's how it's usually done at least in southern Sweden. So after the release cut, you directly conduct mechanical site preparation. But the other alternative recommended by Christer Carlson was to wait with mechanical site preparation at least 3 years and rely on the higher seed production from the overstory. So what Christer found is that by timing soil scarification in relation to reach seed fall, resulted in twice as many seedlings when the mechanical site preparation was done at least after this 3 years from the release cut. And generally, it's this method with postponing mechanical site preparation is recommended in the northern part of Sweden, where rich seed years are not that often as it is in southern Sweden. However, this was never actually tested in any scientific studies. So I mean, both methods were never compared together, which would be quite interesting to look at in the future. Okay, and that was it about the seed fall. And now we can talk about seedling germination and recruitment. So I thought that I will very shortly mention the method that I use at the site in Togel. So in each shelter wood, we have a permanent sampling spots, which were marked with the plastic stick, as you can see on this first picture. And then each time I would come and place the plastic cross exactly in the center of the plot. Cross was always oriented towards the north and placed as flat on the ground as possible. And you can see that on the axis of the cross, we had a scale, which constituted basically a coordinate system. And then using that coordinate system, I was able to register position of each individual seedling. And by repeating this inventory over time, I was able to follow the seedlings, their survival and mortality. So you can see that I did several measurements in time. So in that particular spot, I registered 3 seedlings that that germinated the first year, and all 3 seedlings survived until the last measurement. And you can see that there was 1 new recruitment in the autumn 2018, which also survived until the last measurement. So that's the inventory method that I used to track the seedlings over time. And this is the main result of that study, where on the y-axis you have number of seedlings per square meter. And I would like to warn you from recalculating those numbers per hectare, because those seedlings were observed only on pure mineral soil. So recalculating directly per hectare would be totally wrong. And then you have 3 panels representing different shelter wood densities, from clear cut up to dense shelter wood of 200 trees per hectare. And what is quite striking and quite obvious is that shelter wood density basically had a significant effect of the number of seedlings. And those are results from sites where we, or grounds where we conduct mechanical site preparation. So basically only looking at the mineral soil. And as a sidetrack, I thought that it was quite interesting that in 2018, do you see my cursor?
Yeah.
Yeah. You can see that because different colors, they represent different seedlings cohorts from different years. So as you can, now I lost the cursor. As you can see here, this represents the seedlings that a new recruitment in the year 2018. And if you look at the seed fall to the left, you can see that it was quite a rich seed fall in 2018. So you might have expected more seedling in that year. But as you remember, summer 2018, it was where it was really hot and it was a dry period. So we concluded that although there was a lot of seeds falling on the ground, maybe it was too dry for them to germinate. And then if you look at year 2019 and the recruitment in that year, it was much higher, although the seed fall was quite low. So hypothesis was that the seedling from 2018, the seeds, they couldn't germinate because it was too dry, and maybe some of them managed to survive over winter and then germinate the next season in 2019. But this is just a hypothesis, and most of the previous studies show that actually pine seeds has low probability or low chance to survive winter and germinate the next season. But that was one of our hypotheses which we couldn't actually confirm, but I thought that it was quite interesting. And one study supporting our hypothesis was done with rain shelter woods, where direct seeding was done out in the field in the open clear cut compared to under rain shelter woods. And basically seeds that were seeded under rain shelter woods, they didn't germinate during the first season. And then the second season, when rain shelter was removed, the seeds germinated. So it's basically the same scenario as in our experiment. And yeah, if you keep this picture in mind, and you think that those are the numbers of the seedlings registered in pure mineral soil, we can look at the respective numbers of seedlings on the grounds without any mechanical site preparation. And what is quite striking, that it was very few seedlings that actually germinated on unprepared sites. So actually all the recruitment comes from year 2017. And we concluded that that was because entire spring from May until late June was it was a lot of participation, a lot of rain coming that spring in 2017. So we concluded that maybe humus layer was moist enough for the seeds to seedlings to seeds to germinate, but then most of them die off when the humus layer was dry. And from this study, we concluded that site preparation and list on similar sites of similar fertility, it's actually a must. Probably it would look differently in northern Sweden. We also observe large variation between the two tested sites and between the years. And with this, I would like to move to the results from direct seeding. So what we were interested in was comparison on unimproved seeds from a local stand, and we are both interested in their germination and survival, and we wanted to compare them with seeds collected in seed orchards. So as you can see, both germination rates and survival rates of genetically improved seeds were actually higher. So it gives some indication of better performance of seeds coming from the seed orchards. However, we couldn't prove it with the statistical analysis. And again, there was a large variation between the two tested sites and between the years. Yeah, so that was what we observed. And yeah, I think what we can say about the germination rates, which varied between around 25% up to 30%, is that when you look at the results from similar studies, it was quite comparable. But as I said, it was a large variation between the years and the tested sites. Okay, and finally, we come to results from planting. And in planting, we were testing effects of mechanical site preparation and also different shelter woods densities on both survival, but also seedling growth. And when we look at the survival, you can see that mechanical site preparation resulted in much lower survival compared to sites that were prepared with mechanical site preparation. And the main reason for that was lower damage from pine weevil. So yeah, that's something what Christina Wallet showed in her studies. And we also observed that generally survival was much higher under shelter woods compared to clear cut. And that was again associated to reduced pine weevil damage under shelter wood. And that's about the survival, but we also looked at the seedling growth. So we compared the stem volume calculated for the seedlings on clear cut, sparse, and dense shelter wood. And what is also quite clear, that growth of the seedlings was reduced under the shelter woods. And that's probably because of the high competition from the overstory trees. But what was quite interesting, and what I'm not showing here, that if you look at the same graph representing or showing the leading shoot growth, actually clear cut, those seedlings that grew on the clear cut and in sparse shelter woods, they had quite similar leading shoot growth. But you can see that if you look at the stem volume, the differences between clear-cut and sparse shelter wood are quite large. So we concluded that seedlings that are growing in the sparse shelter wood, they might have a different growth allocation. So what I mean by that is that they suffer from the competition from the overstory trees. So what they want to do is to grow in height as quick as possible, but at the same time they remain quite small in diameter. So they grow a lot in height, but not equally much in diameter. Whereas the seedlings growing under the dense shelter wood of 200 trees, they cannot cope with the competition, and basically they are suffering from the competition, and at some point they would need to be released from the overstory. And I think that discussion is quite relevant in terms of this new definition that Skogsstyrelsen provided about clear-cut free forestry, which include regeneration of Scots pine under shelter wood as a clear-cut free forestry method. And actually the main limitation of using that method is the reduced growth of the seedlings under the dense shelter woods. So then you would need to answer the question when to remove the seedlings from the competition from the overstory. And yeah, I think that was basically it, what I prepared for today. So I would like to thank you for attention, and yeah, if you have any questions.